All right. So now we have learned all of our key things that you need to know to do this unit circle. Yes? Yeah? I mean, I'm telling you, you have. All right. So 90. 90 is our special guy here. Okay. Your 90 is at the top of your unit circle, correct? Um, or actually just look here. 90 is going to be this guy. It doesn't really have an opposite. It doesn't really have an adjacent. It has none of that, right? So when you're looking at 90, you're talking about in terms of its slope, essentially, whether it's 0 or 1, whether it's defined or not. And that's why it doesn't really matter. So at 90 on the x-axis, you are going nowhere, right? You're here. You're just here on the x because it's going to go pew, pew. You go right up. And if my hypotenuse, if my radius is 1, I'm going up 1. So that means your y is 1. So let's talk about drawing that so that you don't think I'm crazy. All right. Here is 0. This is a right angle. So therefore, this is 90. Agreed? That's what a right angle means, is that has to be 90. If I'm going 1 unit, this is 1 unit, then guess what? This is also 1 unit. Guess what? This is also 1 unit. Guess what? This is also 1 unit. So at 90, what would be the ordered pair at 90? I'm at the top, 0, 1. Okay, so with 90, we are going backwards. We're finding the x and y to lead us to our sine and cosine. Does that make sense? Okay, so at 90, we have 0. Well, 0 is our what coordinate? Our x coordinate, and our x coordinate equals our what? X equals our cosine. So therefore, the cosine of 90 is 0. Our 1 is our what coordinate? Our y. Y equals what? Sine. So the sine of 90 equals 1. Okay. This is another one of my favorite tangents to find. So the tan of 90, remember, tangent is your y over your x. What is our y? 1. What is our x? Oh no, 0's in the denominator. So what does that mean? It is undefined. Okay. Oh, that's why I said, oh no, I tried to lead you into it. All right. Remember, it is okay for 0 to be in the numerator. It makes it 0. It is a no-go for 0 to be in the denominator. That makes it undefined. Okay. Okay in the numerator, no-go in the denominator. All right. All right. So tying this all together. When it comes down to where we're at on the unit circle corresponding to angle theta in standard position, the sine of theta is equal to the blank of the point. The what? What coordinate? What value? The y coordinate. We all agree? The cosine of theta is equal to the what? X coordinate. And the tangent is what? Y over X. And that's if it exists. And we say if it exists because it's okay for 0 to be in the numerator. It's going to equal 0. But it's a no-go for 0 to be in the denominator. It's going to be undefined, which is why it says if it exists. All right. So now we're going to put everything together on a beautiful chart. So I'm going to let you take a moment. You're going to fill in this chart with what is the sine, the cosine, and the tangent of 30, 45, and 60 based on what we've done already. It's going to force you to look at what you've done, compile it, and then we're going to keep going from there. Give you a couple minutes to do so. All right, so really quick, looking up here, I had a lot of people asking, where did the radians come from? They came from multiplying pi over 180. How do you go from degrees to radians? You multiply by pi over 180. So this times this equals that, right? That's where that came from. I normally leave it blank and make you convert it to radians, but I did it for you. Now I know next year not to do it for them. Make them convert. So they were like, where did they come from? And I thought we were good. So I did it for you. Trying to play it safe. All right, sine of theta, sine of each angle, we should do, right? Because we went through, I just wanted you to look through the notes and we're just putting it all together because it's kind of got a little cluttered, right? So we're just making it all neat and in one location. Does that make sense? What I want to recall is that sine is our y, cosine is our x, and tan is our y over x. Agree? All right, what is the sine of 30? 1/2. What is the sine of 45? What is the square root of 60? Perfect. What is the cosine of 30? What is the cosine of 45? What is the cosine of 60? Perfect. What is the tan of 30? What is the tan of 45? And what is the tan of 60? That's all I need you to do. Now, all of what we did is in one simple, pretty little location. Make sense? All right. Now, let's talk about our quadrantal angles. So our quadrantal angles are angles that divides our XY plane into our quadrants. Okay? The quadrants that our quadrantal angles create are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Agree? At each one of these, it's a unit circle. So they are one unit from the origin, which is why we know what their ordered pairs are. Yeah? So we work backwards with quadrantal angles. You work from the ordered pairs to figure out your values. So again, sine is our y, cosine is our x, and tangent is our y over x. I know it sounds repetitive, but it's to help you. Okay? So the sine of 0. What is the sine of 0? This is 0, guys. 0. Sine of 0, 0. Because you're looking at the what coordinate? Y. And what is the y coordinate? 0. Okay? The cosine of 0 means I'm looking at the what coordinate? The x. The tan of 0 is going to be your y divided by your x. You see how I set up the box so you just already can look at it? 0 over 1. And that's going to be what? 0, because it's okay for it to be in the numerator. Got it? Yes? You're with me? You're cooking what I'm cooking? You're eating? I don't know. I said that wrong. You're cooking what I'm cooking? No. Yeah, let's do that one. Let's do that one. Let's try pi over 2 in 90. Now we're going to go 90 degrees, which puts us up here, right? This is just a little right turn. And now we're at the coordinates 0, 1. What is the sine of 90 degrees? What is the cosine of 90 degrees? What is the tan of 90 degrees? Undefined, because it's 1 over 0 and 0 is in the denominator. See? Yay? Okay. Now I'm going to go another 90 degrees, which is going to put me at 180. You see her? Yeah. So the sine of 180 is what? 0. Cosine of 180. And therefore, the tan of 180 is 0. I know, it's crazy. I'm going to go another 90 degrees. So what is 180 plus 90? 270. So now we're at 270. The sine of 270 is -1. The cosine of 270 is 0. And the tan is undefined. Okay? I'm going to have you add that when you come all the way back around, that is 360 degrees, right? So 360 has the same values as 0, which means that 2 pi has the same value of 0 radians. Does that make sense? Because you're coming all the way back around. So when you tell someone, oh my gosh, they've done a full 360, that just means they came back to the same dumb person they were. Okay? That's it. That's what that means. That's not a good thing. Okay? a good thing. Unless you were bad, unless you were good and then went through a journey and then came back to be good, then yeah. No, that's good. All right. So now all of these little beautiful things and these two little tables are going to come together on our handy dandy. Okay. It all comes together in our unit circle. Notice this time I was kind and I wrote the radians in for you. Okay. I am going to ask you, we do need colors. We need colors. Your 30s, 45s, and 90s. You need 3 colors if you choose to. You don't have to do it if you don't want it in colors, but it does make it better and visually appealing. The same way. I'm going to go over it. I went over it with you, how to do it. Yeah, you count. Yes. Thanks for listening to me. You count and reduce.
I think that's good math though.
Well, next week we're filling this out, right? Our first quiz is on Tuesday. We're straight everything. Degrees, radians. Yes. They've already done it twice. And dual credit. Well, radians once, but unit circle. All right, here we go.